All right, I do want to welcome you back to Unit 6. This is nomenclature. We're learning how to name chemical compounds. I thought this would be a good place to kind of review everything and make sure that we are all on the same page with regard to knowing how to name chemical compounds. The first thing you have to be able to do is you have to understand what type of compound you're dealing with. Is it ionic? Is it covalent? Are there polyatomic ions involved, or is it transition metals? What's happening in the compound? So let's start with simple ionic compounds. Okay, simple ionic or binary compounds. So the first thing we're going to do is we're going to name the cation, then we're going to name the anion, and we're going to add the IDE ending. So examples would be things like sodium chloride, magnesium bromide, and calcium fluoride. So if you just have a simple ionic compound, want something from the left, something from the right, name the cation, name the anion, then add the IDE ending, the "ide" at the end. Remember to use the switch technique for all ionic compounds, right? The switch technique for all ionic compounds. So that's how to name ionic compounds or simple ionic, binary ionic compounds. Let's talk a little bit about covalent compounds. Well, remember that to name covalently bonded compounds, we're going to have to remember the mono-di-tri-system, right? Don't use the mono on the first cation. On the cation, if there's mono, just name it. For example, CO2 would be carbon dioxide. H2O would be, we could call it water, of course, but in a strict sense, we would call it dihydrogen monoxide. For water, H2O, dihydrogen monoxide. Don't repeat the vowel, by the way. Don't say monoxide, but just say monoxide. CCl4 would be carbon tetrachloride, right? CCl4, there's 4 carbons, carbon tetrachloride, that's covalently bonded compounds. That's how we name those. Let's now turn our attention to ternary ionic compounds. Now, these are going to involve polyatomic ions. What do we mean by a polyatomic ion? Well, we mean a group of atoms that are a unit that have a charge, right? The whole unit has a charge. We said that most of them are negatively charged. They could have -1, -2, -3 charge. There are a few positive charges, and we'll take a look at one actually right now. Ammonium, NH4, is a positively charged polyatomic ion. So NH4 is ammonium. So we call NH4Cl ammonium chloride. Lithium, Li2CO3. Lithium, the CO3 is carbonate. So that's lithium carbonate. CaSO4. We've got calcium sulfate. Calcium sulfate, just like that, right? Okay, next one. NH4, in parentheses, 2CO3. Remember, you don't have to worry about where the parentheses go. If I write the formula, right, I'll take care of where the parentheses go, what the subscripts are, and so forth. You just have to name it, right? So I want you to recognize this time we've got a polyatomic ion for the cation and the anion, both the cation and the anion. NH4 is ammonium, CO3 is carbonate, right? So this is called ammonium carbonate. Ammonium carbonate. All right, let's move on to ionic compounds, but with multivalent or transition metals involved, right? What do we mean by a transition metal? We mean something, a metal from the belly of the periodic table, from that P block of the periodic table. And by and large, they're going to have multiple, I'm going to use the word oxidation number, right? I want to start integrating that into your vocabulary because we're going to be using that terminology a little bit later. But really it just means charge, right? So if we look at CuCl and we want to name this, we're going to recognize that copper is a transition metal, and further, it has multiple possible charges or multiple possible oxidation states, right? And so I have to clarify that. I have to name that. I have to place that information into the name. Copper is a transition metal which could have 2 possible charges, +1 or +2. Well, which one is it? Well, copper there's a 1 here and there's a 1 there as subscripts. That means that there must have been a 1 here. Oh, I said 1 and then I wrote 2. There must have been a +1 right here and a -1 right there. When I did the switch, they came down as a 1 and a 1, right? So that means that the charge on the copper is +1. So I'm going to write the form as the name copper Roman numeral 1 chloride. Copper Roman numeral 1 chloride. Now, what do I do if I've got CuCl2? Well, here we go. The Cu must have had a charge of +2 because I'm showing a 2 down here after the switch. Copper has a 1, so that must have been a -1 after, and we know that's true for the chlorine is the charge of -1 because it's in the 17th column, right? 17th family or group. So it's a copper 2 chloride this time. This time it's copper Roman numeral 2 chloride. And finally, Fe2O3. How do we name this one? We recognize that iron is a transition metal. Further, it has multiple oxidation possibilities or charge possibilities. Which one is it? Well, the 2 came from here as a -2. The 3 came from here as a +3, and therefore iron has a charge of +3. I've got to name it in the compound. I've got to actually say it's iron Roman numeral 3 oxide. Iron oxide is not good enough, right? It's not good enough. All right, let's move on. What I want to do now is actually just practice, right? I think the more we do this, the better we're going to get at it. So let's just do some additional practice problems. And I'm going to run through these fairly quickly because I've already explained the procedure and we've done a number of example problems. I just want to give you some more additional practice so you have the opportunity to look at these one more time. I want to start with molecular compounds. What do we mean by molecular compounds? Compounds involving 2 atoms, both on the right side of the zigzag line, right? So, first one, sulfur dioxide. Sulfur dioxide is going to be SO2. It's covalent, it's molecular, in other words. So we use the monoditri system in the naming, so sulfur dioxide would be SO2. Diphosphorus pentoxide, 2 phosphoruses, 5 oxygens. P2O5 for this one right here. All right. Next one, dinitrogen trioxide this time. Dinitrogen trioxide, N2O3 this time. Next one, phosphorus pentabromine. Bromide, I'm sorry. Phosphorus pentabromide. 1 phosphorus, 5 bromines. So PBr5, just like that. Next is tetrasulfur dinitride. Tetra is 4, di is 2, S4N2, just like that. Next, nitrogen dioxide would be NO2. Nitrogen dioxide is NO2, just like that. And carbon disulfide, CS2. Notice for all of these, both of the atoms are from the right-hand side, or both the elements are from the right-hand side of the zigzag line. Carbon tetrafluoride, we've looked at this one already, CF4. Tetra means 4, so we'll say CF4. Iodine trichloride would be ICl3. ICl3, tri is 3. Oxygen difluoride, 1 oxygen, 2 fluorines, OF2, just like that. Phosphorus trichloride, tri is 3, so PCl3, just like that. Diarsenic trisulfide would be AS2S3, di is 2, tri is 3, so AS2S3, and that completes our molecular compound going from name to formula. Now, let's go from formula to name. Again, these are molecular compounds. CO2, carbon dioxide. Carbon dioxide for the first one. SO3, sulfur trioxide. Sulfur trioxide. N2O4, 2 nitrogens, 4 oxygens, dinitrogen tetroxide. Dinitrogen tetroxide. N2O, dinitrogen monoxide. Okay, dinitrogen monoxide. Next is P3N5, triphosphorus, 3 phosphoruses, and penta, that's 5, pentanitride. Next, silicon triiodide, 1 silicon, 4 iodines, silicon triiodide. Next is Ni3, nitrogen triiodide. Nitrogen triiodide. Silicon dioxide, SiO2, silicon dioxide. These are all covalently bonded compounds. P4O10. We're going to use our deca this time. Tetraphosphorus decoxide. Okay? Just like that. Next, CCl4, carbon tetrachloride, 4 chlorines, carbon tetrachloride. As2O5 would be diarsenic pentoxide. Okay? Try not to say pentaoxide. Don't put 2 vowels. If you do, it's not the end of the world, but try not to do that. NO would be nitrogen monoxide. Nitrogen monoxide for that one right there. All right. So that completes our molecular compounds. Let's look now at simple binary ionic compounds. Simple binary ionic compounds. That means you're dealing with elements from the first, second, or 13th column only, right? And these are just as easy as they can get because you don't have to worry about that monoditride business. You don't have polyatomic ions to deal with. You don't have even transition metals to deal with. These are simple ionic. NaCl, sodium chloride, chlorine, change the INE to IDE, sodium chloride. That's simple. AlF3, ionic, so aluminum fluoride. AlF3, aluminum fluoride. K2O, potassium oxide. There's no mono, no di, nothing like that. It's just potassium oxide. AgCl, silver chloride for that one. Bai2, this one's going to be barium iodide, just like that, barium iodide. Next, rubidium sulfide, Rb2S would be rubidium sulfide. SRF2 would be strontium fluoride. You see how quickly these go for the simple ionic compounds. Next is KBr, would be potassium bromide for that one. Next, zirconium oxide for that one. YF3, we've got yttrium fluoride. YF3 would be yttrium fluoride. LiN, we've got lithium and nitrogen. We're going to call that lithium nitride. And the last one would be Na2S. This is going to be sodium sulfide, and that'll do it for those. Let's go the other way now. Let's take the name and write the formula. Now this was going to be a little bit more tricky because of the fact that, and all of these require a switch, but I'm not going to do it for every one. I'll do it for the first 1 or 2 just to make sure that you know how to do it, but then I'm just going to name the formula because you ought to be able to do this by now, okay? All right, magnesium chloride. I'll tell you what, I'll use this side of scratch paper over here. We've got magnesium. It's coming from the second column of the periodic table. The alkaline earth metal, so it has a charge of +2. Chlorine, that's from the 17th column. It has a charge of -1. So when I do the switch, I get this, MgCl2, and that's what I'll report as my formula given that name, all right? Given that name. Okay, let me do the switch one more time on the second one, and then I'm going to leave the rest up to you. You should know how to do this by now. Lithium oxide, lithium is coming from the first family or group. Oxygen is coming from the 16th group, right, or family. When I do the switch, here's what I get. Li, put a 2 right there, O right there, Li2O, and that would be my final answer. All right? I'm going to run through these fairly quickly. Calcium bromide would be CaBr2. Zinc sulfide would be ZnS. Sodium nitride would be Na3N. Aluminum nitride would be La2O3. Calcium sulfide would be CaS. You check these. Calcium sulfide, CaS. Cesium iodide, CSI. Magnesium oxide, MgO. Potassium sulfide, K2S. Rubidium fluoride, RbF. And we'll finish with beryllium oxide, BeO. All right, folks, I hope this makes sense. I'll see you in the next one. Thanks. Bye-bye.